Okay, here's another explosion piece, and it tells us that two pieces explode and the kinetic energy combined is 17,500 joules. We also know that momentum is going to be conserved in this explosion, so we got our two equations, and with the momentum is the first plus the second. It started at 0, so momentum first is equal to the opposite of the second momentum, but we can just take absolute values and say that m1v1 is going to be equal to m2v2. So m1 is 1.5 times the second mass. And we can put back in there and we find that v2 is 1.5 times the first velocity then. So that tells me that my kinetic energy, the first one, 1/2 m1 v1 squared, but I'm going to put in that m1 is 1.5 times m2. And kinetic energy, the second mass, 1/2 m2 v2 squared. But I put in there that v2 is 1.5 times v1. Well, I square that, so it's 1.5 twice, and then we have v squared. And if we look at the pieces, we have 1/2 m2 times 1.5 v1 squared, and that's just kinetic energy 1. So Ke2 is 1.5 Ke1. We can substitute back over here, and then we can do our algebra, and we go through and we find out kinetic energy 1 is 7,000 joules, and then that could tell us that kinetic energy 2 must be 10,500 joules.